All right, so away we go. We are going to look at two different types of sequences, and it's going to sound kind of like scary vocab, but again, they're just fancy words for things we already do and already know how to do. This first fancy vocab is arithmetic sequence. So an arithmetic sequence describes a list of numbers which each consecutive number is found by adding a constant. We call this constant a common difference. Okay, so this part is going to be really important to us. If you have an arithmetic sequence, that means you are automatically looking for a common difference. All right, so basically what we are going to look at is see if we have added or subtracted a common number to each number in this kind of pattern here, and if we have, it falls into this category of arithmetic sequence. So I'm going to do two examples, and I'm going to have you guys try two examples. Here we go. What you're going to want to do is look between each value. Is there something that I've added to the previous number to get to the next value? So how did I get from 3 to 8? What did I do? Yeah, we added 5. Now, the way you can test this, if that is not your process, you take the second number and you subtract the first number. So 8 minus 3 would give us 5. And we do that with every value. So 13 minus 8 would give us 5. And we're going to write this out because what you need to make sure is that we are consistently adding 5 to all of our values. And I want you to make a little note that to test this, you're going to subtract. So it seems weird because we're adding 5 to every term, but to test to see if it's the same, again, you're going to take the second term and subtract the first. See what you get. Second term, subtract the first. See what you get. If all of these values are the same, which they are in this case, that means that this is an arithmetic sequence. And we would say our common difference is 5. That I is really bad. Let me fix that. So this is an arithmetic sequence with a common difference of 5. You know, notice that this question also asked us one more thing. It asked us to find the next 3 terms. So let's see if you guys can figure out if this is an arithmetic sequence where I'm adding 5 every term, what would be our next 3 values here? Let's see if you guys can get me some numbers. So we went 3, 8, 13, 18, 23, 28. What else? If you know it, you can throw it in the chat. What would be one of our next number? Gabrielle, what do you think our next value would be? I'm adding 5 to every term. After 28, what would be my next number? Yeah, we got 33 for sure. Yep, and then we'd move on. Plus, I think you just accidentally, there we go, 38, and then 43. Good. No, it's fine. It's fine. You just, you started with 20s instead of 30s. You're good. So here we got 33, 38, 43. So our full question was, is this an arithmetic sequence? Which it was. What is the common difference, which we found by subtracting and figuring out what each value was? And then what were the next 3 terms, which we did at the end by adding 5? Let's test out this one. So again, remember, we always do the second term minus the first. So 9 minus 4 is 5. What's 16 minus 9? 7. Uh-oh. These are not the same values. So as soon as you see a difference in our sequence, we're not adding the same number consistently, you can kind of just eliminate this. This is not a sequence. It's not an arithmetic sequence. So I'm going to make a note, not an arithmetic sequence. It doesn't fit that mold. We haven't added the same value every time. All right, I'm going to pause. Can I get a scale of 1 to 5? 1 being I don't get this, 5 being, yeah, I can do this. Where are you guys at? Thank you, Gabrielle. Thank you, Caitlin. Thank you, Shar. Finn and Connor. Oh, thank you, Connor. Awesome. Finn, make sure you're with us. All right, then I'm going to have you guys try these next two. So remember, we want to identify whether this is an arithmetic sequence. Tell me yes or no, it fits that mold. Then after you figure that out, you're going to want to find the common difference if it's a sequence. And then last but not least, figure out those next three terms. And again, this is only if it's a sequence. So I'll give you guys about 35 seconds to go through and try to answer those three questions for both of these problems. Right. Okay, so I asked Connor to do the first one and Shar to do the second one for me. Now, let's start off with some basic questions. So Connor, looking at this first possible sequence, can you tell me, is this or is this not an arithmetic sequence? What do we think? It is. All right, let's verify. So here we go. When we remember, we're subtracting the second term minus the first. So help me out, Connor. 3 minus 5, what would that give us? Well, be careful. Remember, we do the second minus the first. I know our brain wants to do 5 minus 3, but we're actually doing 3 minus 5, which would give us a value of -2. All right, what about 1 minus 3? Again, make sure we're doing 1 minus 3, not 3 minus 1. There we go. Yes, now you've got it. All right, then our next, we're doing 3 minus 1. What will that give us? 3 minus 1? Remember, we did second minus first. Good. So, Connor, look with me. I had -2, -2, and 2. Are those all the same number? No, so this will not be an arithmetic sequence. Actually, I tricked you. So we don't even need to answer the rest of the questions because it's not a pattern. It doesn't work that way. Does that make sense, Connor? Fantastic. All right. Then Shar, you're up for the second one. What do you think here, ma'am? 7. Okay, so for each one, we've added 7. Yep. So do you remember what I would call it when I add 7 every time? What is that? What is that vocab word? Hint, look back at your problem. Somebody help us out. What do I call it? What's that fancy vocab word when we've added 7 every time? There you go. We say our common difference is 7. So, yep, 7 is the number. You just got to tell me what that is. What did we just find? So it is an arithmetic sequence, and our common difference is 7. Good. Then our last question, I wanted to know the next 3 terms. So did you find those, Shar? The next 3 terms here for the sequence? Or could you find those? $47. Yep, you got it. $54. Nice. One more. Let's see if you can get it. 61, good. We add 7 every time. Good job, you guys. All right, I'll pause in case there are any questions. If you have questions, please let me know. That was one type of sequence. And I'm going to be honest, they love these types of questions on like the PSAT and the SAT. Standardized testing loves looking at sequences. Just pausing in case we have a question. All right, I don't see anything in the chat, so I'm going to go into our next frame because we have a different type of sequence. So now we change from arithmetic sequences to geometric sequences. And a geometric sequence describes a list of numbers in which each consecutive term is found by multiplying a non-zero constant. And this, instead of a common difference this time, we call it a common ratio. So again, I want to do the same thing to these. I want to identify if it's a geometric sequence. I want to identify this time what the common ratio would be. And then I want to try and find the next 3 terms if it is in fact a sequence. So before, when we added something every time to test, we took the second term and subtracted the first term. So we kind of did the opposite. If we wanted to see what we added, we subtracted. Here, if we wanted to see what we multiplied, we're going to divide. So what we do is we do this second term divided by the first term. So let's make a little note to ourselves to divide this time. So here we go, 6 divided by 3, which would give us 2. 12 divided by 6, give us 2. And you want to go through all of these just to make sure that they didn't try and trick us with like the last question being a 3 or something, or the last set being a 3. This time, in fact, they did not. Every single one was a 2. So we passed the test. It is a geometric sequence. And we would say the common ratio is 2. Again, this time we said ratio instead of difference because we're dividing to test. Does somebody have the next 3 numbers after 96? And if you need to use a calculator, there's no shame. We're dealing with bigger numbers this time. Our next 3 numbers in this list after 96. Let's see if you guys can figure them out. I apologize. I need more coffee. Trying to caffeinate here. So to get to we tested. To test, we divided. To get to our next term, though, like 48 times 2 will give me 96. So we need to do 96 times 2 and give me a value. Then that number times 2 to give me the next. Then that number times 2 to give me the last one. So 96 times 2, what would that be, guys? Throw it in the chat when you know it. If you need a calculator, no shame. We got calculator apps. Everybody has a phone. 192, nice. 192. Our next one, let me think. 384. Did anybody get the very last one? Close. 768. There we go. I think you just maybe mistyped. All right, so we have our first geometric sequence. Let's look at the second one, and I need everybody to pull out a calculator for me right now. So either on your Chromebook, with your phone, with an actual calculator. You will need a calculator for this one, because as we're looking here, remember we always do the second divided by the first. Our brain, though, when we look at these two numbers, the first 2 numbers in this list, our brain automatically wants to go, oh, 10 divided by 5 is 2. But in actuality, remember, we're dividing we're dividing 5 by 10, not 10 divided by 5. So I need somebody to give me 5 divided by 10. When you have that answer, can you throw it in the chat? 5 divided by 10. And get your calculators out, get them handy. What's 5 divided by 10? Good, it's 0.5. All right, so it's a little bit backwards from what our brain wants it to be. We see 10 and 5, we think 2. 5 divided by 10, though, is 0.5. All right, and we end up with the same thing here. However, 10 divided by 2.5, what do we get? 10 divided by 2.5. Have those calculators handy. Here, remember, you always do the second divided by the first. So we'd actually be doing 2.5 divided by 5. You always do like the next term in the list divided by the term that you're at. So here, like 5 divided by 10 was 0.5. 2.5 divided by 5 is 0.5 as well. Does that make sense, Caitlin? Oh, not always divided by 10. No. Okay, cool. I still didn't get an answer for 10 divided by 2.5. What do we get? I think we're all afraid to pull out our calculators. Is that what's happening? There we go. Thank you, Gabrielle. Yes, we get 4. So as soon as you get a different number, you can stop because you know that this is no longer a sequence. We have differences. There is not a pattern that is visible to us. So we can say, no, this is not a geometric sequence. It's not an arithmetic sequence. We're not adding something. We're not subtracting something. It just doesn't work. All right. So I'm going to pause in case you guys need to check it out for a second. And in a moment, I will have you guys try on your own. We were cruising through our notes today. All right, I'm on frame 7 of our Jamboard. So now again, I want us to try with geometric sequences. So there are 3 things you need to do. First, test to see if it's a geometric sequence. If it is, then you are finding what the common ratio is, and then what the next 3 terms would be. If it is not a sequence, you can stop there. That's all you need to tell me. All right. So again, I'll give you a little bit longer since dividing is a little bit trickier. We'll do 45 seconds this time. All right, you can see I've written some names on there. I want Gabrielle to try and tell me about the first one and Caitlin to try and tell me about the second one. So Gabrielle, we'll start with you over here. I want to know, is this or is this not a geometric sequence? What do you think? It's not. No, it is not. Good job. Because if we look at this, 6 divided by 3 would give me 2. But as soon as you get to 9 divided by 6, you get 1.5, which tells me, nope, it doesn't fit the mold. So it is not a geometric sequence. Good job, Gabrielle. All right, then Caitlin, you are up. What about this one? What do you think? Yes, it is. Did you find our common ratio here? Common ratio is -3. Good job. If we look between all of these, -6 divided by 2 would give me -3. 18 divided by -6 would give me -3. And -54 divided by 18 would also give me -3. All right, then my last question, Caitlin, stay with me. If our common ratio is -3, can you try and give me those next 3 values in our list? Pulling out the calculator. That's why we have them. All right, we got 162. Good. What about the next one? What do you think? Yeah, -486. And then last but not least, this is a big number. Oh, good. It's actually going to be positive 1458 though, because remember we took a negative here and we multiplied it by a negative down here. So good number, wrong sign. All right, I'm going to pause. I want to know on a scale of 1 to 5, 1 being I don't get this, 5 being I got this. I want to hear from everybody in the chat. Where are we at, you guys? We already looked at adding to get new sequences. Now we did dividing and multiplying to look at new sequences. Also, if you're struggling, now is a great time to ask a question. All right, I'm seeing 4s and 5s. That's pretty good. Now, this is our last 2.0 skill. So this is going to be our last 2.0 that you're going to see on your quiz on Friday. Very exciting stuff.